The Art of Code Review, Improving Team Quality. Chapter 1, The Invisible Backbone, Understanding Code Review. Imagine trying to write a complex novel entirely on your own, never allowing another pair of eyes to read your draft. You might catch most of your typos and grammatical errors, certainly, but what about plot holes? Inconsistent character development? Or simply a passage that, while technically correct, could be phrased far more elegantly? The chances are your final work would suffer. Now, imagine building a critical piece of software, a system that processes life-saving medical data, manages financial transactions, or even just handles your company's daily operations without ever having another developer examine the underlying code. The consequences can be far more severe than a poorly received novel. Crashes, security breaches, data corruption, or simply a system so unwieldy that new features become impossible to implement are all very real possibilities. Enter code review. It's often seen as a necessary chore, a gateway to merge code, or perhaps a simple bug-finding utility. But that perspective barely scratches the surface. Code review is, in fact, the invisible backbone of high-quality software development, a fundamental practice that underpins not just the technical excellence of a product, but also the health, knowledge, and collaborative spirit of a development team. Think of it this way: your code is your creation, a testament to your problem-solving skills. But like any creative endeavor, it benefits immensely from a fresh perspective, a critical eye, and constructive engagement. This book is dedicated to exploring and mastering that critical engagement, transforming code review from a mundane task into an empowering art form. What is code review? At its simplest, code review is the systematic examination of source code. It involves one or more people, other than the original author, looking at code with the intent of identifying potential issues, suggesting improvements, and ensuring adherence to standards. While this definition sounds straightforward, the practice itself can take many forms. Pair programming. Two developers work side by side at one workstation, collaboratively writing, designing, and continuously reviewing code in real time. This is perhaps the most immediate form of code review, with feedback happening milliseconds after a line is typed. Over-the-shoulder reviews, an informal method where one developer simply looks over another's shoulder, observing their code and offering immediate feedback or suggestions. Great for small, quick checks. Formal inspections, e.g., Fagan inspections, a highly structured, meeting-based process where code is meticulously reviewed by a team with defined roles: moderator, reader, recorder, inspector. Though resource-intensive, these can be incredibly effective for highly critical systems. Asynchronous pull requests, PRS, or merge requests, MRS. This is the most prevalent form in modern software development. A developer creates a new branch of code, makes their changes, and then submits a pull request to merge those changes into the main codebase. Other developers then review the proposed changes asynchronously, adding comments, suggestions, and ultimately approving or requesting changes before the code is merged. This method forms the primary focus of this book. Historically, code review isn't a new concept. As early as 1976, IBM researcher Michael Fagan formalized the process with Fagan inspections, a meticulous method designed to catch errors early in the software development lifecycle. While the tools and methodologies have evolved dramatically, moving from paper printouts and physical meetings to sophisticated web-based platforms integrated with version control systems, the core principle remains the same: a shared commitment to quality through peer examination. Why is it more than just finding bugs? When you first hear code review, you likely think of bug detection. And yes, code review is an excellent bug-finding mechanism. A fresh pair of eyes can often spot a logical error, an off-by-one mistake, or an overlooked edge case that the original author, deep in their problem-solving context, might miss. However, reducing code review to mere bug hunting is like saying editing a novel is just about catching typos. It misses the vast landscape of benefits. Consider these deeper advantages that extend far beyond simply squashing defects. Knowledge sharing and bus factor reduction. When team members review each other's code, they gain insights into different parts of the system, different problem-solving approaches, and the overall architecture. This spreads critical knowledge across the team, reducing the bus factor, the risk to a project if key team members were suddenly unavailable. Mentorship and skill development. Code review is a powerful learning tool. Senior developers can mentor junior colleagues by explaining best practices, design patterns, and idiomatic uses of languages or frameworks. Conversely, junior developers can sometimes offer fresh perspectives or identify areas for simplification. Everyone learns from the collective wisdom. Improved code quality and consistency. Beyond outright bugs, reviews address code readability, maintainability, performance, and adherence to team-defined standards. This leads to a more consistent, easier to understand, and ultimately more robust code base, reducing long-term technical debt. Fostering a culture of collaboration and ownership. Code review moves ownership of the code base from individual developers to the entire team. It encourages open communication, constructive debate, and a shared responsibility for the product's quality. When done well, it builds trust and psychological safety within the team. These benefits highlight that code review is not just a technical process, it's a social and educational one. It's a dynamic interaction that leverages collective intelligence for mutual growth and superior outcomes. The art of code review. Calling something an art might seem out of place in the precise, logical world of software engineering. Yet, the most impactful code reviews involve far more than just technical precision. They demand empathy, understanding that code is often a reflection of a developer's effort, and approaching feedback with respect and consideration. Communication skills, the ability to articulate complex technical ideas clearly, concisely, and constructively, focusing on the code, not the person. Critical thinking, moving beyond surface-level observations to identify underlying architectural flaws or systemic issues. Patience and humility, recognizing that everyone makes mistakes and that learning is a continuous journey for both the author and the reviewer. When code review is practiced with these skills, it transforms from a bureaucratic hurdle into a truly collaborative learning experience. It becomes not just about identifying what is wrong, but also helping to understand why and guiding towards how to make it better. It's the socio-technical dance that elevates good code into great software. What this book will cover. This book is your comprehensive guide to mastering the art of code review. We will embark on a journey that moves beyond basic definitions to practical application and cultural transformation. We will cover the profound benefits that extend beyond simple bug detection, showcasing how review builds team knowledge and robust systems. The critical human element, delving into the psychology of giving and receiving feedback, and how to cultivate a culture of trust and constructive criticism. Practical strategies for preparing your code for review and giving impactful, actionable feedback that genuinely helps. The tools and techniques that streamline the review process, from version control system features to static analysis and the emerging role of artificial intelligence. How to integrate code review seamlessly into various development workflows, regardless of your team's specific practices. Advanced topics for specialized reviews, such as security, performance, and reviewing legacy code. Methods for measuring the success of your review process, ensuring continuous improvement. Ultimately, how to build a thriving culture of quality where code review is a celebrated cornerstone of collaboration and excellence. Just as an architect benefits from a peer looking over blueprints to spot potential structural weaknesses before construction begins, or a professional editor helps refine a manuscript before it goes to print. Code review provides a vital, early check on the integrity and quality of software. It's this iterative, collaborative process that builds stronger code, more knowledgeable teams, and ultimately, more successful software. By the end of this book, you will be equipped to transform your team's code review process into its most powerful tool for quality and collaboration. Chapter 2, Beyond Bug Hunting, the multifaceted benefits of code review. In the previous chapter, we established that code review is far more than just a bug-finding mechanism. If you've ever participated in a review solely focused on catching errors, you might find it an arduous and often demoralizing task. Such a narrow focus misses the forest for the trees, overlooking the profound, multifaceted benefits that elevate code review from a mere chore to a powerful engine of team development and software excellence. Let's dive deeper into these often overlooked advantages, illustrating how effective code review can transform your team and your product. Enhanced code quality and reliability. This is perhaps the most immediate and tangible benefit, even when we look beyond simple bugs. Code review acts as a critical checkpoint, a final expert appraisal before changes are committed and potentially deployed. Catching subtle errors and edge cases. While automated tests are invaluable, they can't cover every conceivable scenario or logical flow. A human reviewer, especially one with different experiences or a fresh perspective, can identify subtle logical errors, overlooked edge cases, or potential race conditions that lead to unpredictable behavior in production. This proactive detection dramatically reduces the likelihood of costly defects escaping into the wild. Reduced technical debt. Code review is your first line of defense against the accumulation of technical debt. Reviewers can spot code that is overly complex, difficult to understand, or might be hard to modify in the future. By advocating for clearer designs, better abstractions, and simpler implementations early on, teams prevent the growth of a tangled, unmaintainable codebase that slows down future development. Increase system stability. When code is consistently reviewed for quality, clarity, and adherence to best practices, the entire system becomes more robust and reliable. Fewer defects translate to fewer production incidents, less downtime, and ultimately, a more stable and trustworthy product for your users. Consider the experience of Team Phoenix, a software group struggling with frequent production outages. Their existing code review process consisted primarily of a quick, looks good to me, LGTM check. After a particularly disruptive outage that cost several days of development time to fix, their leadership mandated a change. They implemented a new review policy focusing on architectural soundness, test coverage, and clarity, not just bug catching. Within 6 months, Team Phoenix saw a 40% reduction in critical bugs escaping to production, and their system uptime improved dramatically. This wasn't just about finding bugs, it was about building a culture that prevented them in the first place. Knowledge sharing and team efficacy, one of the most powerful, yet often undervalued, aspects of code review is its role in disseminating knowledge across the team. Spreading domain and architectural knowledge. When developers review code in areas they might not frequently work on, they gain an understanding of other parts of the system and the business logic they implement. This cross-pollination of knowledge builds a more resilient team where expertise isn't siloed. Imagine a developer learning how the authentication module works by reviewing a related change to the user profile system. This prevents knowledge from being concentrated in just one or two individuals. Reducing the bus factor. Closely related to knowledge sharing, the bus factor refers to the minimum number of team members who, if they were hit by a bus or won the lottery, would immediately put the project in jeopardy. By ensuring that multiple team members understand critical parts of the codebase through reviewing, you significantly lower your bus factor, making your team more robust and less susceptible to the departure of a single individual. Creating shared ownership. When code is reviewed by the team, it becomes the team's code, not just the individual authors. This fosters a sense of collective responsibility and pride in the quality of the codebase. It shifts the mindset from my code to our code, promoting a common goal and reducing territoriality. Code review, in this sense, acts as a continuous brain dump where individual knowledge becomes collective wisdom. Think of it like a sports team. A quarterback can't win a game alone. The entire team needs to understand the playbook, anticipate each other's moves, and communicate effectively. Code review is the constant practice session where everyone learns the plays, understands their teammates' roles, and improves their own performance. Mentorship and skill development. For any growing technical organization, continuous learning is paramount. Code review provides a unique and effective platform for ongoing professional development. Accelerated learning for junior developers. For new or less experienced developers, code review is an invaluable masterclass. They observe senior developers' thought processes, learn best practices by seeing them applied or improved upon, and receive direct, contextualized feedback on their own code. This direct feedback loop is often far more effective than abstract training courses. Refining best practices for senior developers, even experienced developers benefit. Reviewing others' code forces them to articulate their reasoning, solidify their understanding of principles, and sometimes even reconsider their own long-held assumptions. It's an opportunity to teach, and, in teaching, to learn anew. Feedback on naming, clarity, and design. Beyond catching bugs, reviewers can provide invaluable feedback on code readability, naming conventions, architectural design choices, and approaches to testing. These are crucial skills that often go unaddressed in formal education, but are vital for professional growth. We've all seen developers, often junior, who seem to grow exponentially in a short period. Often, this acceleration is directly attributable to working in a team with a strong, constructive code review culture. Sarah, a new intern at a tech startup, initially struggled with design patterns and writing concise code. Her tech lead, Mark, consistently provided detailed, empathetic feedback on her pull requests, often pointing her to specific resources or suggesting alternative approaches with clear explanations. Within 6 months, Sarah was contributing high-quality, elegant solutions, a growth trajectory significantly faster than interns in other teams who received only surface-level reviews. Code consistency and standards adherence. Software projects, especially as they grow, can quickly become an unmanageable patchwork of different styles and approaches if left unchecked. Code review helps maintain order and consistency, enforcing style guides. Whether it's indentation, variable naming, or comment conventions, consistent styling improves readability and reduces cognitive load for anyone reading the code. Reviewers ensure adherence to agreed-upon style guides, often complementing automated linters. Promoting architectural patterns. Code review checks that new features align with the existing architectural principles and design patterns. This prevents individual developers from introducing idiosyncratic solutions that deviate from the team's chosen path, ensuring the system evolves coherently. Upholding security best practices. Reviewers can serve as a vital human layer of security. They can identify opportunities for common vulnerabilities, like SQL injection, cross-site scripting, or unsecured API endpoints, before they become embedded in the codebase, significantly strengthening the product's security posture. Consistent code is like a consistent language. Everyone speaks it the same way, making communication effortless. Without code review, you might end up with a dozen different dialects in your codebase, requiring mental translation every time you switch modules. Fostering a culture of quality and collaboration. Perhaps the most profound impact of effective code review is its ability to shape team culture. Building trust and psychological safety. When feedback is delivered respectfully and received openly, it builds trust. Team members learn they can rely on each other to catch mistakes, offer help, and contribute constructively. This fosters psychological safety, the belief that one can speak up with ideas, questions, concerns, or mistakes without fear of punishment or humiliation. As Google's famous Project Aristotle found, psychological safety is the single most important factor in distinguishing high-performing teams. Encouraging open communication. The review process, by its nature, promotes open dialogue about technical choices, trade-offs, and solutions. It encourages developers to articulate their reasoning and to collectively arrive at the best possible outcome. Shared responsibility. When everyone reviews and everyone's code gets reviewed, it reinforces the idea that software development is a team sport. The success or failure of a feature isn't solely on the author. It's a collective achievement or a collective lesson learned. Imagine a team where defects are treated not as individual failures, but as opportunities for collective learning, where a challenging technical solution is debated and refined through respectful discussion, leading to a stronger outcome. This is the hallmark of a healthy, high-performing team, and code review is one of the most effective ways to cultivate such an environment. It's the ritual that reinforces team identity and shared commitment to excellence. In summary, to view code review merely as a bug-hunting exercise is to miss its deepest value. It's an investment in your team's collective intelligence, a powerful mechanism for knowledge transfer, a continuous education platform, and a foundational practice for building a resilient, high-quality product. When embraced fully, code review transforms from a checkpoint into a dynamic, collaborative engine that drives continuous improvement, reduces risk, and fosters a vibrant, growth-oriented engineering culture. In the next chapter, we'll delve into the very human aspects of this powerful practice, exploring the psychology behind giving and receiving feedback effectively. Chapter 3: The Human Element. Navigating the psychology of feedback. We've explored the technical and organizational benefits of code review, painting a picture of its invaluable contribution to software quality and team efficacy. But here's the often overlooked truth. Code review, at its heart, is a human interaction. It's about people giving specific, often critical feedback to other people about something they've created. And whenever humans and criticism meet, psychology comes immediately into play. Ignoring this human element is a common trap. Many teams focus solely on the what of code review, what tools to use, what style guides to follow, and neglect the how to communicate effectively, how to foster psychological safety, and how to manage the inherent emotional responses. This oversight can turn a potentially powerful process into a source of friction, defensiveness, and resentment. In this chapter, we'll delve into the psychological landscape of code review, equipping you with the understanding and skills to navigate it with empathy and effectiveness. Ego and insecurity, the author's perspective. For the author of the code, submitting a pull request can feel remarkably like stepping onto a stage or presenting a creative work for critique. Code is often an extension of the developer's intellect, skill, and effort. It represents hours of thinking, debugging, and problem-solving. When that creation is then scrutinized, it's natural for the author to feel a sense of vulnerability. Consider these common psychological pitfalls from the author's side. Code as an extension of self. Developers pour their creativity and problem-solving abilities into their code. When it receives criticism, even constructive criticism, it can feel like a personal attack on their intelligence or competence, rather than an objective commentary on their work. "My code is ugly" can too easily translate to "I am an ugly coder." Fear of judgment. No one likes to be wrong or to have their mistakes highlighted, especially in front of peers. There can be an underlying anxiety about appearing less skilled, less knowledgeable, or lazy. This fear can lead to defensiveness or a closed-off attitude when receiving feedback. Confirmation bias. Authors might unconsciously seek validation for their chosen solution. When a reviewer suggests an alternative, it can be perceived as an invalidation of their original approach, even if the suggestion is genuinely superior. Imagine Alex, a relatively new engineer, working diligently for days on a complex feature. He's proud of his solution and opens a pull request. The first reviewer, Clara, immediately points out an architectural flaw, suggesting a complete reapproach. Alex's immediate reaction might not be gratitude for the early catch, but rather a sting of humiliation or frustration at having his hard work seemingly dismissed. Understanding this innate human reaction is the first step towards building a compassionate review process. Power dynamics and constructive criticism, the reviewer's challenge. Just as authors face psychological hurdles, reviewers carry their own set of responsibilities and potential pitfalls. The act of reviewing inherently places the reviewer in a position of perceived authority or expertise. How this power is wielded is crucial. The temptation to dictate versus collaborate. It's easy for a reviewer, especially one with more experience, to simply state "do X" or "change Y" while direct. This approach can stifle learning, breed resentment, and turn the review into a series of commands rather than a collaborative discussion. Ensuring feedback is helpful, not hurtful. The goal is to improve the code and the author's skills, not to diminish their confidence. This requires careful consideration of tone, wording, and intent. A comment like, "This is a terrible way to do it," is dismissive and damaging, whereas, "Have you considered approach B?" It might handle edge cases more elegantly due to Principle Z, is constructive. Understanding context while avoiding assumptions. A reviewer rarely has the full context that the author possesses. It's easy to critique a piece of code in isolation without understanding the constraints, previous decisions, or deadlines that influenced its creation. Making assumptions rather than asking clarifying questions can lead to irrelevant or frustrating feedback. Reviewers must be mindful that their comments carry weight and can be interpreted in ways they didn't intend. A poorly worded suggestion, even with good intent, can land like a personal attack. Psychological safety, building trust in your team. The concept of psychological safety is paramount in creating a healthy code review environment. Coined by Harvard Business School professor Amy Edmondson, psychological safety is defined as a shared belief held by members of a team that the team is safe for interpersonal risk-taking. In other words, people feel safe to speak up, ask questions, admit mistakes, and offer ideas without fear of negative consequences. How does this relate to code review? Code review as a trust builder or breaker. When code review is a safe space, where feedback is respectful, non-judgmental, and focused on learning, it actively builds trust. Team members learn they can share imperfect work and receive support. Conversely, if reviews are hostile, shaming, or overly critical, they erode trust and psychological safety, leading developers to avoid opening PRs, hide mistakes, or produce safe but uninspired code. Learning from mistakes. In a psychologically safe environment, mistakes are seen as learning opportunities, not as failures. A developer whose error is constructively pointed out and who feels supported in correcting it will learn more effectively than one who feels shamed and retreats. Google's extensive research on team dynamics, Project Aristotle, famously identified psychological safety as the single most important factor for high-performing teams, overshadowing individual intelligence or experience. Building psychological safety means establishing mutual respect. It means reviewers understand the author's vulnerability, and authors understand the reviewer's intent to help. Empathy and emotional intelligence in technical communication. Given the human dynamics, both reviewers and authors must cultivate empathy and emotional intelligence. Empathy, the ability to understand and share the feelings of another. For a reviewer, this means imagining how their comment might be received. For an author, it means understanding the reviewer's perspective and the context from which they are providing feedback. Emotional intelligence, the capacity to be aware of, control, and express one's emotions, and to handle interpersonal relationships judiciously and empathetically. Here's how to apply these in practice. Choose your words carefully. Avoid absolute statements. This is wrong, judgmental language, you poorly designed this, or accusatory tones. Instead, use softer, more collaborative phrasing. Focus on the code, not the coder. Frame feedback around the code's behavior or structure, not the author's intelligence or effort. This function is hard to test, is better than you wrote untestable code. Explain the why. Rather than just saying change X, explain why X is being suggested, e.g., change X to improve readability for future maintainers, or change X to prevent a potential race condition. This turns a directive into a teachable moment. Use I statements. Instead of you should use a different loop. Try, I often find a for each loop clearer in these situations. This emphasizes it as your perspective, not an objective universal truth. Praise in public, critique in private, if needed. While most code review happens publicly, if a comment is particularly sensitive or could lead to an extended, potentially heated debate, consider taking it offline to a direct message or voice call. And always remember to highlight what's done well. Positive feedback, great job on that complex algorithm, is just as important as constructive criticism. An illustrative example, a junior developer, Maya, submits a PR. A senior developer, Ben, notices a less than optimal algorithm. A bad comment might be, this algorithm is inefficient and will cause performance issues. Rewrite it. A better, empathetic comment could be, thanks for this contribution, Maya. I see you've opted for algorithm A here. For the anticipated scale of data, I'm concerned it might lead to performance bottlenecks. Have you considered algorithm B? It has better asymptotic complexity for large inputs and could offer significant gains here. Happy to discuss if you like. Establishing a no-blame culture. The ideal code review environment operates within a no-blame culture. This means focus on system and process improvement. When an error is found, the question isn't, whose fault is this? But how did our system allow this to happen, and how can we prevent it in the future? Perhaps the existing tests were insufficient, or the guidelines for a certain part of the codebase were unclear. Mistakes as learning opportunities. Every defect, every suboptimal solution found during review is a chance for the team to learn and grow. Documenting these lessons and integrating them into future practices strengthens the entire team. Celebrating lessons learned. Instead of hiding mistakes, reflect openly on them in team retrospectives. What did we learn from that challenging review? How can we apply that knowledge moving forward? This reinforces the idea that learning, even from errors, is valued. A truly no-blame culture allows authors to feel safe submitting code, knowing that even if issues are found, the conversation will be about betterment, not blame. It allows reviewers to provide honest feedback without fear of causing undue offense. Summary: the human element is not a side effect of code review, it is its very essence. By understanding the psychology of both the author's vulnerability and the reviewer's influence, and by actively cultivating empathy, emotional intelligence, and psychological safety, teams can transform code review from a source of potential friction into a powerful amplifier of learning, collaboration, and ultimately, code quality. In the next chapter, we'll move from these essential interpersonal dynamics to the practical considerations of how and when to initiate and manage the review process itself. Chapter 4. Setting the stage. What, when, and how much to review. You've mastered the art of empathy, equipped yourself with the understanding of human psychology, and embraced the collaborative spirit essential for effective code review. Now, let's get practical. Before code is even submitted for review, a series of crucial decisions and preparations can significantly impact the efficiency and efficacy of the entire process. Just as a chef meticulously preps ingredients before cooking, a developer should carefully stage their changes for review. This chapter delves into these foundational aspects: defining the scope of what gets reviewed, determining the optimal size for a reviewable chunk of code, and understanding the best time to initiate and conclude the review process. Defining the scope. What constitutes a reviewable change? Not all changes are created equal, and not all changes should be reviewed in the same way or even at the same time. Establishing clear boundaries for what constitutes a reviewable unit is critical for avoiding confusion, context switching, and bottlenecks. Generally, any change destined for the main codebase should pass through a review. This includes new features, the addition of new functionality, bug fixes, corrections to existing defects, refactoring, restructuring existing code without changing its external behavior, performance improvements, changes aimed at making code run faster or use fewer resources, security patches, addressing vulnerabilities, infrastructure as code, ISC definitions, changes to configuration files for servers, databases, or deployment pipelines are just as critical as application code. Documentation updates, significant changes to internal developer documentation that explain how the code works. While the what is broad, it's crucial to consider the how. The ideal review unit is typically encapsulated in an atomic commit or, more commonly, an atomic pull request. This means the change represents a single, cohesive logical unit of work. What to avoid mixing? Formatting styling changes with logic changes. Resist the urge to fix all the styling issues in a file when you're changing a bug or feature. These should ideally be separate PRs or handled by automated formatters. Mixing them clutters the diff and makes it harder for reviewers to focus on the substantive changes. Large refactors with feature development. If you need to refactor a significant portion of code to properly implement a new feature, consider submitting the refactor as a separate, pre-approved PR before adding the new feature code. This allows the refactor to be reviewed for its own merit and correctness, simplifying the subsequent feature review. Unrelated changes. Avoid bundling multiple unrelated bug fixes or features into a single PR. Each should have its own dedicated review. The goal is to provide reviewers with a focused, manageable chunk of work that addresses a single purpose. This clarity makes the review process smoother and more effective. Optimal pull request size. The sweet spot. Perhaps the single most impactful decision you can make to improve your code review efficiency and quality is to manage the size of your pull requests. This is a delicate balance, and there's a sweet spot that maximizes benefits. Why small PRs are better? Faster review times. Reviewers can process small changes much more quickly. This reduces context switching, cognitive load, and the likelihood of reviews piling up. A study by Cisco found that reviews of 200 to 400 lines of code, LOC, had a 70 to 90% defect detection rate, while reviews over 400 LOC saw detection rates drop significantly. Easier comprehension. A reviewer can hold a limited amount of information in their short-term memory. Smaller changes are easier to grasp fully, leading to more thorough and insightful feedback. Lower risk of introducing bugs. The research is clear. Larger changes correlate with higher defect rates. When complex changes are broken down into smaller, atomic units, each unit is less likely to contain hidden bugs, and any bugs introduced are easier to pinpoint. Less context switching for reviewer. When a reviewer picks up a large PR, they might need to dedicate a significant block of time, potentially disrupting their own work. Smaller PRs allow reviewers to fit reviews into natural breaks, reducing disruption. Faster merges and integration. Small, atomic changes can be merged more frequently, reducing merge conflicts and allowing new features to be integrated into the main branch faster. This directly supports continuous integration practices. Empirical data. Various industry reports and studies suggest that the ideal PR size is often between 10 to 200 lines of code changed, LOC, with some even advocating for an upper limit of around 150 LOC. These numbers are not rigid rules, but rather indicative benchmarks. The key is that the change should be digestible in a reasonable amount of time, say 15 to 60 minutes. Strategies for breaking down large changes. Feature flags. Implement a large feature behind a feature flag. This allows you to merge incomplete code into the main branch without affecting users, and then incrementally build out the feature in a series of small, reviewable PRs. Only when the feature is complete and stable is the flag switched on. Refactor first, feature second. As mentioned, separate significant refactoring into its own PR. Step-by-step implementation. For complex features, break them down into their logical components. For example, a new user authentication system might involve separate PRs for database schema changes, core authentication logic without UI, user interface components, integration of UI with logic, refactoring security practices based on learning. Abstract out dependent logic. If a new feature requires changes to an existing utility or service, pull those changes out into a separate PR that can be reviewed and merged independently. Resist the temptation to cram everything into one massive change. It might seem faster initially, but it invariably slows down the review process, increases the likelihood of bugs, and makes debugging a nightmare. Timing is everything. When to initiate a review. Opening a pull request isn't just about finishing your code, it's about optimizing for the team's efficiency and context. Don't wait until the last minute. Submitting a PR immediately before a deployment deadline or the end of the workday week can create unnecessary pressure on reviewers. Plan to submit your code with enough buffer time for review, feedback, and potential revisions. Consider reviewer availability. If you know key reviewers are in meetings all morning, on vacation, or out sick, consider holding off on opening a PR until they're available. Conversely, some teams have dedicated review hours, where everyone sets aside time to get through pending reviews. The daily ritual of reviewing. Encourage a habit where reviewers check for new PRs at the start of their day, after lunch, or at other regular intervals. This predictable rhythm helps prevent PRs from languishing. Avoid reviewing when tired or stressed. As a reviewer, if you're mentally fatigued or under significant personal stress, defer reviewing until you can give it your full attention. A quick, unthoughtful LGTM can be as detrimental as a hostile review. A general guideline is to submit your PRs as early in the day as possible, preferably before lunch. This gives reviewers ample time to look at it, and for you to respond to initial comments before the day ends. Prerequisites for a smooth review, self-review and tests. Before you even think about opening that pull request, There are a few critical steps an author must take to ensure the review is productive, respectful of the reviewer's time, and focused on the right things. The self-review, this is the single most underrated step. Before submitting, review your own code just as critically as you expect others to. Read through the diff line by line. Does it make sense? Are there any obvious typos, formatting errors, or unnecessary comments? Are variable names clear? Is the logic easy to follow? Did you leave any debugging code, e.g., console log statements? Does the change actually solve the problem it set out to solve? Anecdote: senior developers often find 30 to 50% of their own issues during self-review before others even see the code. This saves reviewer time and reduces back and forth. Ensure all tests pass and are sufficient. Your changes should ideally be accompanied by appropriate automated tests, unit, integration, end-to-end, that cover the new functionality and demonstrate that existing functionality hasn't regressed. Run all relevant tests locally before pushing. Ensure your CI/CD pipeline runs these tests automatically on the PR. Reviewers rely heavily on tests to understand the intended behavior of your code. Good tests explain the code better than any comment. Clean code and style adherence. All code should adhere to the team's established style guides. Utilize automated formatters like Prettier, Black, Go FMT, and linters to catch obvious stylistic issues. This frees up human reviewers to focus on logic, architecture, and potential edge cases, rather than nitpicking about indentation. Craft a clear and comprehensive pull request description. The PR description is your opportunity to provide context and guide your reviewers. What problem does this PR solve? Link to issue trackers like Jira, Trello, Asana. How does it solve it? Briefly describe the approach. What are the key changes? E.g., added new endpoint/API/user/profile, refactored user service to use user repository. Are there any known trade-offs or assumptions? How can reviewers test this locally? Provide clear steps. Screenshots, videos. For UI changes, visual aids are invaluable. By investing time in these prerequisites, you show respect for your reviewers' time and expertise, dramatically streamlining the entire review process. Choosing the right review model. While this book primarily focuses on the pull request, asynchronous model, it's worth understanding where your team's approach sits within the broader spectrum. Pre-commit reviews, e.g., pull requests. How it works: code is reviewed before it's merged into the main development branch. This is currently the most popular model and the one we primarily discuss. Advantages: prevents problematic code from ever entering the main branch, catches issues early. Disadvantages: can be a bottleneck if reviews are slow, requires reviewers to actively block merges. Post-commit reviews, e.g., pair programming, audits. How it works: code is reviewed after it has already been committed and potentially merged. Pair programming is a continuous form of post-commit review. Formal audits can also happen periodically. Advantages: faster individual development cycle as merges are not blocked, continuous learning in the case of pair programming. Disadvantages: if issues are found, they are already in the main branch, potentially causing more disruption to fix, less control over the quality of merged code. Most teams find a balance. The dominant model is often pre-commit for new features and significant changes, sometimes augmented by pair programming for complex problems or post-commit audits for critical security pathways. Your team must decide which model or hybrid best suits your velocity, risk tolerance, and team culture. Summary: the outcome of a code review is heavily influenced by the quality of the preparation. By meticulously defining the scope of your changes, breaking down large tasks into small, digestible units, initiating reviews thoughtfully, and rigorously self-reviewing with comprehensive tests and clear descriptions, you set the stage for a smooth, efficient, and ultimately more valuable code review experience. This careful staging respects your reviewers' time, elevates the discussion beyond superficialities, and ensures that the focus remains on building high-quality, maintainable software. With this foundation laid, we can now turn our attention to the specific techniques for giving and receiving the invaluable feedback that defines the art of code review. Chapter 5. The Reviewer's Playbook. Giving great, actionable feedback. You've received a notification. a new pull request awaits your review. This isn't merely a task on your to-do list. It's an opportunity to improve the code base, to mentor a colleague, to share knowledge, and to reinforce your team's commitment to quality. As a reviewer, you are a guardian of the code base and a coach to its contributors. Your feedback, when delivered skillfully, can transform good code into great code and a good developer into a better one. This chapter provides a reviewer's playbook, outlining the strategies and techniques for giving feedback that is impactful, actionable, and truly constructive. Understanding the author's context and intent. Before you even start commenting on lines of code, pause. The most common mistake reviewers make is diving straight into the diff without understanding the broader picture. Read the pull request description and linked issues first. This is non-negotiable. The author has hopefully invested time in explaining what their code does and why it does it. This context is crucial. What problem is this PR trying to solve? What are the stated goals and non-goals? Are there any known trade-offs or design decisions the author has already considered? Familiarize yourself with any associated tickets, e.g., Jira, Asana, to grasp the full business context. Explore the tests. Good tests explain the expected behavior of the code. Reviewing the tests first, or alongside the code, can provide invaluable insights into the author's intent and how they've thought about edge cases. Don't assume. Ask clarifying questions. If something in the PR description or code isn't clear, don't guess. Ask, could you explain the reasoning behind this if statement? I'm not immediately seeing the edge case it handles. This shows you're engaged and helps the author clarify their thinking, often leading them to spot issues themselves. By understanding the context, you avoid making irrelevant suggestions, asking questions already answered, or misinterpreting the author's intentions. It demonstrates respect for their work and sets a collaborative tone. Focusing your review. Prioritizing important issues. Not all feedback is equally valuable. An effective reviewer knows how to prioritize and distinguish between critical issues and minor nits. Your goal is to guide the author towards high-impact improvements, not to rewrite their code to match your personal preferences. The two-pass approach recommended. First pass, high-level review, architectural and design. Step back from the line-by-line details. Focus on the big picture. Architecture. Does this change fit well within the existing system architecture? Does it introduce new dependencies or break existing conventions? Design. Are the classes, functions, and modules well designed? Do they adhere to principles like single responsibility, open-closed, etc.? Is the solution elegant or overly complex? Security. Are there obvious security vulnerabilities introduced? Performance. Could this approach lead to performance bottlenecks at scale? Test coverage. Are there sufficient tests? Do they cover the happy path, edge cases, and error conditions? Overall approach. Does this PR actually solve the right problem in an effective way? If you find a major flaw here, stop. Address this fundamental issue first. There's no point nitpicking syntax if the entire approach is wrong. Discuss it with the author. Second pass, detailed review, readability, and implementation details. Once you're satisfied with the overall approach, dive into the specifics. Readability. Is the code easy to understand? Are variable and function names clear? Are comments necessary and helpful? Maintainability. Will this code be easy to modify and extend in the future? Clarity. Is the logic clear and concise? Can it be simplified? Style conventions. Does it adhere to the team's style guide and coding conventions? Note. Ideally, linters and formatters handle most of this, freeing you up. Edge cases. Are there any specific tricky scenarios that might break the code? Avoiding bycasheting and how to handle it. Bycasheting, or Parkinson's law of triviality, refers to the tendency for people to give disproportionate weight to trivial issues. Everyone understands a bike shed, so everyone weighs in on its color. Even if vastly more important, complex issues regarding the core project are left unaddressed. In code review, this translates to heated debates over minor stylistic preferences when an architectural flaw goes unnoticed. Enforce automated formatting and linting. This removes subjective style issues from human review entirely. Prioritize. Ask yourself, is this comment a suggestion to improve the code or just my personal preference? If it's a preference and the current code is acceptable, consider letting it go. Use the nits label. Some teams add a prefix like nit or optional to minor comments, indicating they are low-priority suggestions and don't necessarily need to be addressed before merge. The art of constructive criticism, why versus what. This is where the art truly shines. Your comments should be helpful and educational, not just correctional. The single most important rule, explain the why. Beyond what. Don't just say, change foo to bar. Explain why. Instead say, consider changing foo to bar, the what. Because bar more clearly reflects the intention of this variable in the context of the user authentication service, the why. Provide alternatives, but don't dictate. This could be simplified using a map instead of a for loop. Map is generally preferred here for its immutability and conciseness when transforming arrays. Frame as suggestions or questions instead of. You need to add a try-catch block here. Try, what error handling strategy do we want here? A try-catch might be appropriate to gracefully handle external API failures. Instead of, this logic belongs in the user service. Try, would it make sense to move this logic, related to user details, into the user service to centralize user operations? Just thinking about separation of concerns. Practical examples. Less effective direct, vague, more effective constructive, explains why, offers guidance. Bad naming. Consider renaming TMP to customer map. It would improve readability by clarifying its purpose. This is insecure. I see a potential SQL injection vulnerability here. Using parameterized queries instead would prevent malicious input from being executed as code. Wrong approach. This approach might become difficult to scale when we hit X users. Have you considered using a caching layer here to reduce database load? Needs tests. Could you add a unit test for this new calculate total? Function, specifically covering cases where the input list is empty or contains negative values. It would give us more confidence in production. Refactor this. This function seems to be doing two things, fetching data and formatting it. Perhaps we could refactor it into separate fetch data and format data. Functions for better single responsibility and testability. Remember, your tone matters. Choose words that are collaborative and supportive. A well-placed, thanks for putting this together, or good work on handling that complex logic, can set a positive tone for the entire review. Using questions to guide, not dictate. Asking questions is one of the most powerful tools in a reviewer's arsenal. It encourages the author to think critically about their own code, leading to deeper understanding and self-correction, rather than simply applying a fix without internalizing the lesson. Examples of effective questions. What happens if customer ID is null during this operation? Highlights an edge case. Have you considered the performance implications of fetching all transactions even if we only need the latest one? Prompts consideration of optimization. Could we simplify this block by extracting it into a private helper method called isValidEmail? Suggests a refactor without demanding it. Is this piece of business logic documented anywhere? Or is it implicit? Points towards documentation needs. Is there a unit test that specifically asserts the mapping of field A to field B? Checks test coverage. Questions foster a dialogue, inviting the author to share their reasoning, learn from potential gaps, and even teach the reviewer something new. Identifying common review traps. As a reviewer, be aware of these common pitfalls. Nitpicking by caching. Getting bogged down in minor, subjective preferences that don't significantly impact the code's functionality, readability, or maintainability. If a linter can handle it, let the linter do it. If it's a minor stylistic choice that's consistent, often it's best to let it go. Scope creep, suggesting major refactors, new features, or unrelated enhancements that are outside the scope of the current pull request. This significantly delays the merge and frustrates the author. If you have a good idea for a separate improvement, suggest it as a follow-up task or new issue. LGTM looks good to me without substance, providing a cursory approval without a thorough review. This undermines the purpose of code review and can let bugs or poor quality code slip through. If you don't have time for a full review, politely decline or defer. Delaying reviews. Becoming a bottleneck for the team. Timeliness is crucial for maintaining flow and preventing work in progress from piling up. Aim for a quick turnaround wherever possible, even if it's just to acknowledge the PR or ask for clarification. Personal bias attacks. allowing personal feelings, past disagreements, or a desire to prove superiority to influence your remarks. Stick to facts, code, and objective reasoning. Conclusion. Reviewing is a skill. Mastering the art of giving great, actionable feedback is a skill that develops with practice, conscious effort, and a genuine desire to help others improve. It requires putting ego aside, cultivating empathy, and remembering that the ultimate goal is to build better software and a stronger team. Every PR is an opportunity to contribute positively to both. In the next chapter, we swing the pendulum back to the author, equipping them with the strategies to prepare their code for review and, crucially, how to respond gracefully and effectively to the feedback they receive. Chapter 6. The Author's Guide. Preparing and responding to feedback gracefully. You've poured your efforts into solving a problem, crafting a solution, and writing the code. Now, it's time to share your creation with your peers, allowing them to scrutinize it and offer improvements. For many developers, this can be a moment of anxiety. Will my code be picked apart? Will my mistakes be exposed? Just as reviewing is an art, so too is being an author in the code review process. Your role isn't passive, it's active. By meticulously preparing your code for review and then engaging with feedback thoughtfully and gracefully, you can transform a potentially stressful experience into a highly productive one, accelerating your learning and fostering team collaboration. Preparing your code for review. The work of a good author begins long before the pull request is opened. It starts with a mindset. How can I make this review as easy and productive as possible for my colleagues? This shows respect for their time and effort and sets a positive tone. Write clean, readable code. This should be your default. Use meaningful variable and function names. Keep functions short and focused. Break down complex logic into smaller, manageable chunks. Consistent formatting, preferably enforced by automated tools, is crucial. Clear code is its own best documentation, making it easier for reviewers to understand your intentions without having to unravel convoluted logic. Craft excellent commit messages. Each commit message should tell a story, what changed and why. A good message isn't just a summary, it's context. Subject line 50 to 72 chars, concise summary e.g., feet. Add user profile endpoint. Body optional but recommended. Explain why the change was made, what problem it solves, and any important context, e.g., trade-offs considered, alternative approaches discarded. Link to the relevant issue tracker. Create a comprehensive pull request description. This is arguably the most critical piece of preparation for review. It's your opportunity to guide the reviewer, provide crucial context, and proactively address potential questions. Clear title, summarize the PR's purpose, e.g., implement user registration flow. Problem statement, briefly reiterate the problem this PR addresses, link to issue ticket. Solution overview, high-level explanation of how your code solves the problem. Don't dive into line-by-line minutiae, but explain architectural choices or key algorithms. Technical details implementation notes. Any specific challenges, design decisions, or areas where you'd particularly like feedback. Testing instructions, crucial for complex changes. How can the reviewer test this feature locally? Provide steps, data, or credentials if necessary. Screenshots, videos. For UI/UX changes, visuals are invaluable. Known issues trade-offs. Be transparent about any limitations or compromises you made. This builds trust and shows foresight. Checklist. Consider including a pre-review checklist, e.g., all tests pass, code linted, updated documentation, to ensure you've done your due diligence. Example, some teams use PR templates to standardize this information, ensuring all necessary context is provided. Ensure tests are passing and comprehensive. Don't submit code that breaks tests. Run all relevant tests locally before pushing. More importantly, ensure your tests adequately cover the new functionality and protect against regressions. Automated CI/CD pipelines should run tests on every PR, serving as a safety net. Self-review, the most underestimated step. Before you even open the pull request, review your own code. Step away from your keyboard for 15 to 30 minutes, then come back and look at your Git diff with fresh eyes. You'll be amazed at how many issues, typos, uncommented logic, potential bugs, style violations you can catch yourself. This not only saves your reviewers time, but also sharpens your own critical eye. It's the ultimate act of respect for your team. By following these steps, you minimize the noise in the review, allowing your colleagues to focus on truly valuable feedback related to design, architecture, and potential edge cases, rather than stylistic corrections or missing context. Receiving feedback, detaching ego from code. Once you open that pull request, your code stops being your code and starts becoming our code. This transition requires a significant act of detachment. Your code is not you. This is the most crucial psychological shift. Your code is a product of your effort, but it is not inherently you. Feedback on your code is not feedback on your worth as a person or a developer. It's an objective critique of a piece of software aimed at making it better. Embracing this perspective is liberating. Embrace the learning opportunity. Every comment, every suggestion, every question is an opportunity to learn. Even if you ultimately disagree with a suggestion, the discussion around it deepens your understanding of the codebase, the problem domain, or a different perspective. Avoid defensiveness. When feedback hits hard, our natural instinct is often to defend our choices. However, defensiveness closes down communication. It signals to the reviewer that their effort is unwelcome. Instead of immediately countering, pause, breathe, and consider the comment from their perspective. Even if a comment is poorly phrased, try to extract the underlying technical concern. Acknowledge and appreciate. Reviewing takes time and mental effort. Thank your reviewers for their input. A simple, "Thanks for the thorough review," goes a long way in fostering a positive review culture. Remember Alex from Chapter 3, who felt a sting of humiliation when his code was critiqued. The enlightened Alex learns to view Clara's comment not as a personal attack, but as an architectural insight he might not have considered, helping him grow as an engineer. Responding effectively. Clarification, agreement, or discussion. Your response to feedback is just as important as the feedback itself. It shapes the dialogue, demonstrates your professionalism, and brings the PR closer to merging. Address every comment, even if it's just to say, "Done." Clarification. If a comment isn't clear or you don't understand the context, ask for clarification. Could you elaborate on what you mean by tight coupling here? Are you referring to the direct dependency on auth service? I'm not sure I understand the suggested alternative. Could you provide a small code snippet or a link to an example? Agreement and action. If you agree with a suggestion, confirm that you'll make the change. Good point. I'll update the error message to be more user-friendly. You're right, this logic can be simplified. I've pushed a commit with the suggested refactor. Once you've made the change, reply to the comment indicating it's done or addressed in commit X. Then resolve the conversation if your tool allows. Discussion and justification. When to push back. There will be times when you disagree with a comment or you believe your current approach is superior given certain constraints. This is perfectly normal and healthy. The key is to engage in respectful, technical discussion, not emotional debate. Provide technical justification. Explain why your current approach is chosen, referencing specific constraints, trade-offs, performance implications, or future considerations. I considered option B, but based on our current performance requirements and the need for backward compatibility with older client versions, option A, my current implementation, struck a better balance. What are your thoughts on that trade-off? This function might seem overly complex, but it needs to handle a very specific edge case, JIRA 123, that the simpler approach wouldn't cover. Focus on data and facts. Support your arguments with data, performance metrics, or established patterns principles. Focus on project needs, not personal preference. Frame your defense in terms of what's best for the project, not just what you prefer. Elevate the discussion. If a disagreement persists after a couple of exchanges, or if it involves a significant architectural decision, suggest moving it offline. This seems like a deeper architectural discussion. Would you be open to a quick 15-minute call to discuss this approach further? Let's pair on this. I think seeing it in action might clarify my reasoning. Involve a third party. Maybe we can loop in Team Lead X for their opinion on this design choice. Be flexible. While pushing back is sometimes necessary, also know when to concede. Not every change needs to perfectly align with your initial vision. Sometimes a good enough solution that satisfies your reviewer and ships quickly is better than a perfect one that never merges. Iterating on feedback, the cycle of improvement. Code review is an iterative process. You submit, receive feedback, make changes, and then request another review. Push incremental updates. Instead of waiting to address all comments at once, if a significant review is ongoing, consider pushing changes in smaller commits as you address specific feedback points. This allows reviewers to see progress and re-review in stages. Request re-reviews. Once you've addressed a set of comments, let your reviewer know so they can re-examine the updated code. Many tools allow you to mark conversations as resolved and only show changes since the last review. Be patient. Reviewers have their own work. While you want your PR merged quickly, understand that immediate re-review isn't always possible. Follow up politely after a reasonable amount of time if your PR has gone stale. Conclusion: a collaborative endeavor. Being a good author in the code review process means being proactive, transparent, and open-minded. It requires you to detach your ego from your code, embrace feedback as a gift, and engage in respectful dialogue. When both authors and reviewers master their respective roles, the code review process ceases to be a gatekeeping hurdle and transforms into a powerful, collaborative engine for learning, growth, and the continuous delivery of high-quality software. Up next, we'll dive into the tools and techniques that can streamline this entire process, allowing teams to focus more on the valuable human interaction and less on the mechanics. Chapter 7: Tools and Techniques. Automating and streamlining your workflow. The human elements and psychological dynamics explored in previous chapters form the heart of effective code review. However, the sheer volume and complexity of modern software development demand more than just human eyeballs. Thankfully, a rich ecosystem of tools exists to automate the mundane, enforce consistency, identify common pitfalls, and streamline the entire code review workflow. These tools are not a replacement for thoughtful human judgment. Rather, they are powerful amplifiers. By offloading repetitive checks to machines, they free up human reviewers to focus on higher-value activities: architectural soundness, nuanced design decisions, business logic, and mentorship. This chapter explores the essential tools and techniques that can make your code review process more efficient, consistent, and less prone to human error. Version control systems as review platforms: GitHub, GitLab, Bitbucket. The ubiquitous pull request, PR, or merge request, Mr., is the modern cornerstone of asynchronous code review. Largely enabled by distributed version control systems like Git and their hosted platforms. These platforms provide a centralized hub for all code changes and the discussions around them. Key features for code review: diff viewers. Visualize changes side-by-side diffs, highlighting additions, deletions, and modifications. Inline comments. The ability to add comments directly on specific lines of code, fostering contextual discussions. Comment threads and resolutions. Organized conversations around specific points, with the ability to resolve discussions once addressed. Suggestions. Many platforms allow reviewers to suggest specific code changes that the author can apply with a single click. This streamlines minor fixes. Approval mechanisms. Formal approve or request changes actions to indicate whether a PR meets review criteria. Branch protection rules, critical for enforcing review policies. These rules can prevent merging until a minimum number of approvals are met. All required status checks, e.g., CI/CD builds, tests, linting, pass successfully. All conversation threads are resolved. Integrations. Tie-ins with issue trackers, CI/CD pipelines, and project management tools, providing a single source of truth for the change and its full context. Leveraging these platforms. Become proficient with your team's chosen platform. Utilize Markdown for clear formatting in comments, liberally use suggestions for minor improvements, and leverage the Resolve Conversation feature to keep discussions tidy. Static analysis tools, finding bugs before humans do. Static application security testing, SAST, and other static analysis tools examine source code without executing it, identifying potential bugs, security vulnerabilities, and quality issues. They are like automated code quality cops. How they work: They parse code, build an abstract syntax tree, and apply a set of rules to detect patterns that indicate problems. Benefits: early bug detection. Catch issues before compilation or runtime, significantly reducing the cost of fixing them. Consistency and standard enforcement. Ensure adherence to coding standards, naming conventions, and architectural best practices across the codebase. Security vulnerability identification. Pinpoint common security flaws, e.g., SQL injection, insecure deserialization, cross-site scripting, that might be overlooked by human review alone. Reduced reviewer burden. Automate the detection of common, repetitive errors, freeing human reviewers to focus on complex logical and architectural concerns. Limitations: false positives. Can occasionally flag valid code as problematic, requiring manual triage. Contextual blindness. Struggle with complex business logic or design patterns that require deeper understanding. They analyze what the code says, not always what it means. Examples: Sonar Quebec multilanguage, EaseLint JavaScript, Pylint Python, Checkstyle Java, RuboCop, Ruby. Integration. Integrate static analysis tools into your continuous integration (CI) pipeline. Every pull request submission should trigger these checks, with results visible directly in the PR. This ensures a consistent baseline of quality before human review. Linters and formatters, enforcing style consistency. While static analysis tools focus on correctness and potential defects, linters and formatters are solely concerned with style, consistency, and readability. Linters analyze code for programmatic and stylistic errors, but specifically relating to consistency, e.g., missing semicolons, unused variables, inconsistent indentation. EaseLint JavaScript, Flake8 Python, Goffmt Go. Formatters automatically reformat code to adhere to a predefined style guide, e.g., indentation, spacing, line breaks. Prettier JavaScript, CSS, HTML, Black Python, Goffmt Go. Why they are essential for code review. Eliminate bytecoding. Automated formatting eliminates debates over trivial stylistic preferences, allowing human reviewers to concentrate on substantive issues. Improve readability. Consistent code is easier to read and understand across the entire team, reducing cognitive load. Faster reviews. Reviewers don't waste time pointing out formatting errors that could be fixed automatically. Lower barrier to entry. New team members can quickly contribute without having to memorize complex style guides. Integration. Editor integration. Configure developer IDEs to automatically format code on save. Pre-commit hooks. Use tools like Husky, JavaScript, or Git hooks to run linters/formatters before a commit is even created. This ensures only properly formatted code gets committed. CI/CD pipeline. Add linter/formatter checks to your CI build process as a mandatory step for PRs. CI/CD integration. Quality gates for every PR. Continuous integration, CI, and continuous delivery deployment, CD. Pipelines are critical automation for software development. Integrating code, review effectively into your CI/CD process, creates powerful quality gates. How it works: when a pull request is opened, your CI pipeline automatically triggers a series of checks. Build. Compiles the code to ensure it's syntactically correct and can be built. Automated tests. Runs unit tests, integration tests, and potentially end-to-end tests to verify functionality and prevent regressions. Static analysis and linting. Executes the tools discussed above to check for quality, style, and security issues. Dependency scanning. Checks for known vulnerabilities in third-party libraries. Benefits: immediate feedback. Developers get instant feedback on the basic quality and correctness of their code. Consistent quality ensures a predefined level of quality for every single change. Security enforcement catches many security issues automatically, reduces manual burden, lessens the need for human reviewers to manually check for basic errors. Enables branch protection. PRs cannot be merged until all these automated checks pass, enforcing quality before code enters the main branch. This integration transforms potential problems into easily fixable issues detected early in the development cycle, long before a human reviewer even begins their work. Specialized code review tools. while Git platforms provide the core functionality. Some organizations, particularly those with highly regulated environments or complex workflows, might opt for dedicated code review tools offering more granular control, reporting, and workflow customization. Examples: Atlassian Crucible, SmartBear Collaborator, Jarrett, often used for large open-source projects. Features: more formal workflows with defined roles and checklists. Advanced reporting and analytics on review metrics, e.g., review time, defect density. Integration with specific enterprise-grade tools. Support for pre-commit, pre-merge, and post-commit review processes. For most teams, the built-in capabilities of GitHub, GitLab, or Bitbucket, combined with CI/CD and static analysis tools, are more than sufficient. Leveraging AI in code review, current and future. The landscape of software development is undergoing a transformation with the advent of advanced AI tools. Code review is a prime area for AI assistance. Current state: intelligent code completion generation. Tools like GitHub Copilot and similar offerings generate code based on context, reducing boilerplate and allowing developers to focus on higher-level logic. While not direct review tools, they influence the code being written. Automated suggestion engines. Some platforms are starting to offer AI-powered suggestions during review, such as identifying common anti-patterns, suggesting optimizations, or flagging potential errors that static analysis might miss. Smart linters. AI can learn from project-specific codebases to create more relevant and less noisy linting rules. Future potential. The role of AI in code review is rapidly evolving. We can anticipate context-aware analysis. AI that understands the intent of the code, not just its syntax, allowing it to provide more nuanced feedback, e.g. This implementation doesn't align with the established pattern for handling user authentication in our codebase. Automated summarization of PRs. AI could generate concise summaries of large PRs or complex changes, making it easier for human reviewers to grasp the core of what they need to review. Semi-automated review comments. AI could generate initial review comments based on predefined rules, common vulnerabilities, or even learned patterns from past reviews. Human reviewers would then refine and add their specific insights. Anomaly detection. Identifying unusual code contributions or deviations from typical development patterns that might signal a problem or a security risk. The role of AI: an assistant, not a replacement. It's crucial to understand that AI will augment, not replace, human code review. The human element of mentorship, empathy, understanding nuanced business requirements, weighing trade-offs, and deep architectural insights will remain indispensable. AI will free humans from the tedious, repetitive checks, allowing them to truly focus on the art of code review. Summary: modern code review is a hybrid endeavor, combining the sharp intellect and empathy of human reviewers with the tireless precision of automated tools. By strategically deploying version control platforms, static analysis, linters, formatters, and a robust CI/CD pipeline, teams can create a highly efficient and effective code review process. These tools serve as the foundation, ensuring a baseline of quality and consistency, allowing the human element to truly elevate the code and the team. With the mechanics in place, we can now look at integrating this process naturally into your daily workflow. Chapter 8, Code Review and Practice, integrating into your workflow. We've explored the theoretical benefits of code review, navigated the psychology of feedback, and familiarized ourselves with the powerful arsenal of tools available. Now, it's time to bring it all together. The true measure of a successful code review process lies not just in understanding its components, but in how seamlessly and effectively it integrates into your team's daily development workflow. Code review shouldn't feel like an external imposition or a last-minute chore. It should be a natural, embedded part of how your team builds software. This chapter will delve into different models of code review and provide practical strategies for making it an efficient, empowering, and indispensable part of your team's operations. Different models of code review. While the asynchronous pull request (PR) model is dominant, it's not the only way to review code. Understanding the various approaches helps you choose the right fit for different situations or even adopt a hybrid model. Asynchronous pull requests, APRs. How it works. As detailed in previous chapters, a developer pushes code to a branch, opens a PR mister, and reviewers provide feedback over time, typically through a web interface. Pros. Highly flexible time-wise, reviewers can engage when convenient, promotes clear documentation, PR descriptions, comments, excellent for distributed teams, creates an auditable trail of feedback. Cons. Can create bottlenecks if reviewers are slow, requires good communication to avoid misunderstandings due to lack of real-time interaction, potential for context loss. Best for most feature development, bug fixes, teams that value clear record keeping. Pair programming. How it works. Two developers work together at one workstation, physically or virtually. One driver writes code, while the other navigator reviews, strategizes, and offers real-time suggestions. Roles often switch. Pros. Instant feedback and continuous review, deep knowledge sharing, high code quality right from inception, fewer context switches, excellent for training and onboarding. Cons. Resource-intensive, two developers for one task, requires good communication and compatibility between pairs, can be tiring for long sessions. Best for complex problems, architectural spikes, critical bug fixes, onboarding new team members, training senior skills. It's the ultimate continuous code review. Over-the-shoulder reviews. How it works. Informal. One developer literally leans over another's shoulder or shares their screen remotely to quickly review a small change, discuss a code snippet, or get immediate feedback. Pros. Extremely fast feedback, useful for minor changes or quick clarifications, highly interactive. Cons. Not formal or auditable, can be disruptive, limited in scope, easy to miss issues compared to a dedicated review. Best for trivial bug fixes, minor refactors, quick sanity checks, discussing a specific function or problem. Formal inspections/walkthroughs, e.g., Fagan inspections. How it works. A highly structured, meeting-based process with defined roles, moderator, reader, recorder, inspector. Participants carefully inspect code against a checklist, often with pre-meeting preparation. Pros. Exceedingly thorough, high defect detection rates for critical systems, creates a shared understanding amongst participants. Cons. Very high overhead, time, resources, scheduling, can be slow and bureaucratic. Best for mission-critical software, highly regulated industries, complex architectural changes, or when extremely high assurance is required. Not practical for daily development. Most successful teams blend these approaches. APRs serve as the default for most changes, augmented by pair programming for complex work and informal over-the-shoulder checks for minor issues. Formal inspections are rarely used for daily tasks, but might be considered for major releases or security-critical sections. Establishing team standards and guidelines. Consistency is key to an efficient review process. Your team should agree on a set of common practices and document them clearly. Code review checklist. Create a concise checklist that reviewers can use to ensure comprehensive coverage. This can include items like, does it meet the requirements? Are tests sufficient? Is it clear and readable? Is documentation updated, if applicable? Are there any security concerns? Does it adhere to coding standards? Tip. This can be integrated directly into your PR template. Pull request templates. Standardize the information authors provide in their PR descriptions. This ensures crucial context is never missed. Most Git platforms support configurable PR templates. Team rules for review. Agree on some simple ground rules. Review turnaround time, RTT goal. E.g., all non-urgent PRs should receive first review within X hours. This manages expectations and prevents bottlenecks. Approvals needed. E.g., every PR needs at least 2 approvals from distinct team members. Blocking versus non-blocking comments. How do you indicate a comment that must be addressed versus a suggestion? E.g., blocking, NIT, optional. Communication protocol. How should disagreements be handled? E.g., discuss orally, involve a third party. Documentation. Keep these guidelines accessible. A simple Confluence page, a well-commented Markdown file in your repository, or a team wiki are good places. Regularly revisit and update them in team retrospectives. These standards provide clarity, reduce friction, and make the review process more predictable and fair for everyone involved. Onboarding new team members to your review process. A team's code review culture is often one of the first things a new hire encounters. Make it a positive and educational experience. Introduce them early. During initial onboarding, explain your team's code review philosophy, tools, and guidelines. Encourage them to review others' code. Even if they don't feel confident making technical suggestions, encourage new hires to read other people's PRs. This is an excellent way to learn the code base, common patterns, and design principles. They can also ask clarifying questions. Why did you choose this data structure? Their fresh perspective can also reveal areas of unclear code or documentation. Pair them with experienced reviewers. Have a senior developer pair review with the new hire, walking them through their thought process, how they look for issues, and how they phrase comments. Start with small PRs. Encourage new hires to submit very small, low-risk PRs initially, e.g., documentation updates, minor bug fixes to get comfortable with the process. Provide extra support and constructive feedback on their first few PRs. Model good behavior. Existing team members and leads should consistently demonstrate the desired review behavior: prompt, respectful, and constructive engagement. Handling large or complex changes. Strategies for success. Despite best efforts, some changes are inherently large or complex. Don't let these become an insurmountable review burden. Break down the change. As discussed in Chapter 4, this is paramount. If a single change takes days to review, it's too big. Aim for PRs that can be reviewed in under an hour. Feature flags/dark launches. If breaking down is difficult, implement the large feature behind a feature flag. This allows you to incrementally merge work into the main branch unconditionally without affecting users. The full feature can then be turned on when ready. Trunk-based development with reviews. This strategy, where all developers commit directly to the main branch frequently, relies heavily on very small, easily reviewable changes, often enabled by feature flags. It keeps the mainline clean and releasable. Dedicated review sessions. For truly architectural shifts or high-risk changes, consider a synchronous meeting. The author can walk through the design and propose changes, answering questions in real time. This can be more efficient than countless asynchronous comments. Involve key stakeholders early. If a change impacts multiple teams or areas, involve representatives from those teams in the review process, or at least inform them. Consider a design review before any code is written, ensuring alignment. Reviewing documentation, tests, and configuration files. Code review principles aren't limited to application code. Their application extends to other critical artifacts. Documentation. Review internal documentation, e.g., API specifications, architectural diagrams, runbooks, for clarity, accuracy, completeness, and adherence to team standards. Clear documentation reduces cognitive load for future developers. Tests. Review the tests themselves for correctness, coverage, and readability. Are they valid tests? Do they truly test what they claim? Are they easy to understand? Configuration files and infrastructure as code, ISC. Treat configuration files, e.g., YAML, XML, JSON, and ISC scripts, e.g., Terraform, CloudFormation, Ansible, with the same rigor as application code. Errors here can have far-reaching consequences in production environments. Review for security, robustness, correctness, and adherence to infrastructure patterns. The ultimate goal of software quality applies to all assets that contribute to the running system, not just the application code itself. Summary: integrating code review into your team's workflow requires intentionality. By choosing appropriate review models, establishing clear standards, effectively onboarding new members, and employing strategies for managing complex changes, you can weave code review into the fabric of your daily development rituals. It becomes less of a separate task and more of a continuous conversation around quality, collaboration, and learning. With these practical aspects covered, we can now turn our attention to more specialized and advanced topics in code review, preparing you for even greater challenges and opportunities. Chapter 9: Advanced Topics and Special Cases in Code Review. So far, we've covered the fundamentals of code review. emphasizing its human element, collaborative benefits, and practical integration into daily workflows. But software development is a vast and varied landscape, and some domains demand specialized attention during review. This chapter delves into advanced topics and specific scenarios where the general principles of code review need to be adapted or augmented for maximum effectiveness. Security code review, identifying vulnerabilities. Security is paramount in nearly every software application. While security testing tools, SAST, DAST, are invaluable, human security code review provides a critical layer of defense that automated tools cannot fully replicate. It requires a different mindset, actively looking for weaknesses, not just bugs. Understanding common vulnerabilities. Reviewers need a foundational understanding of common attack vectors and vulnerabilities, such as those cataloged by the OWASP Top 10, e.g., injection, broken authentication, cross-site scripting, insecure design. Knowledge of specific framework security features and pitfalls is also essential. A threat modeling mindset. Approach the code as a potential attacker. Where are the entry points? What data is sensitive? What are the trust boundaries? Can an attacker manipulate input to achieve unintended outcomes? Key areas to scrutinize. Input validation. Is all user input, from web forms, APIs, command lines, files, properly validated, sanitized, and escaped before use in queries, displays, or other operations? Authentication and authorization. Are authentication mechanisms robust? Are access controls correctly implemented? Who can do what? Is sensitive data protected during transmission and storage? Error handling. Do error messages reveal sensitive information, e.g., stack traces, internal server details? Configuration management. Are sensitive configurations, e.g., API keys, database credentials, stored securely? Dependencies. Are third-party libraries up-to-date and free from known vulnerabilities? Automated dependency scanners help here. Logging. Is sufficient logging in place for security events, but without logging sensitive data? Security champions. For larger teams, designate security champions. Developers with an interest in security who receive additional training and act as internal consultants and expert reviewers for security-critical PRs. Case study. A team developing an e-commerce platform had a rigorous general code review process, but security vulnerabilities still occasionally slipped through. They began a practice of targeted security reviews, where, for highly sensitive modules like payment processing or user authentication, a developer with specialized security training would perform a dedicated review, often looking for specific attack patterns. This led to a significant reduction in found vulnerabilities during subsequent penetration testing. Performance code review. Optimizing for speed and efficiency. Performance often sits at a cross-section of algorithms, system design, and resource management. Reviewers trained in performance can spot inefficiencies before they manifest as critical bottlenecks. Algorithmic complexity, big O. Can a linear search be replaced by a hash map lookup, O, N versus O, 1? Is there a loop inside a loop that could be optimized? Database interactions. Are there N+1 queries? Is data being fetched unnecessarily? Are indexes being utilized? Is the ORM being used efficiently? Resource management. Are connections, database, network, or file handles being opened and properly closed? Are memory leaks present? Concurrency. Are locks or synchronization mechanisms correct and preventing deadlocks or race conditions without introducing unnecessary contention? Network calls. Are external API calls minimized, batched, or cached appropriately? Caching strategy. Is data being cached effectively where appropriate? Is cache invalidation handled correctly? Trade-offs. Performance is rarely free. It often comes at the cost of readability, development time, or increased complexity. A good performance reviewer understands these trade-offs and ensures that optimizations are justifiable and appropriate for the context. Use tooling preemptively. Encourage authors to use profiling tools or local load testing before submitting performance-critical code. This provides data-driven evidence for performance claims. Reviewing legacy code. Strategies for incremental improvement. Legacy code, often characterized by its age, lack of consistent style, minimal tests, and outdated dependencies presents unique review challenges. The goal isn't to rewrite everything, but to improve it incrementally. Focus on small, safe changes. Resist the urge to refactor an entire module in a single PR when working on legacy code. Make the minimum necessary change to implement the feature or fix the bug. The Boy Scout rule: leave the campsite cleaner than you found it. Whenever touching legacy code, make one small improvement. Add a test, clarify a comment, rename an ambiguous variable, extract a small function. Add tests first. Before making any change, try to add characterization tests that capture the current, often undocumented, behavior of the legacy code. This acts as a safety net when you start modifying. Isolate and encapsulate. Where possible, identify seams in the legacy code and try to isolate new logic or refactored parts, encapsulating them with clearer interfaces. Review for readability, not perfection. While striving for improvement, acknowledge that fixing every deficiency in legacy code is impractical. Focus on making the portion you touched easier to understand and maintain for the next person. Refactorings as separate changes. If a significant refactor is warranted, propose it as a separate initiative or PR, explaining its business value, e.g., reduced maintenance, enabling new features. Code review for different paradigms. Different programming paradigms emphasize different principles, which should be reflected in the review process. Functional programming, FP, immutability. Are data structures modified in place, or are new ones created? Prefer new ones. Pure functions. Do functions produce the same output for the same input and have no side effects? Higher order functions. Are map, filter, reduce used effectively where appropriate? Referential transparency. Can expressions be replaced with their values without changing program behavior? Object-oriented programming, OOP. Solid principles. Are single responsibility, open-closed, Liskov substitution, interface segregation, and dependency inversion followed? Design patterns. Are appropriate design patterns used, and are they implemented correctly? Encapsulation. Are class responsibilities clearly defined? Is internal state protected? Inheritance vs. composition. Is composition preferred over inheritance where possible to promote flexibility? Microservices. API contracts. Are interservice API contracts clear, well-defined, e.g., Open API spec, and backward compatible? Resilience and error handling. How do services handle transient failures, retries, and circuit breakers? Data consistency. How is eventual consistency managed across services? Observability. Are logs, metrics, and traces sufficient for distributed tracing and monitoring? Data science machine learning, DSML code. Reproducibility. Can the exact results be reproduced given the same data and code? Data pipelines. Is data ingestion, transformation, and storage robust and versioned? Model versioning. How are different iterations of models managed and tracked? Bias and fairness. Is there any potential for data or algorithmic bias? Interpretability. Can the model's decisions be understood or explained? Resource management. Are heavy computations optimized for memory, CPU, or GPU? Reviewing design documents and architectural proposals. Code review is powerful, but catching design flaws after code is written is often far too late. Applying review principles to design documents and architectural proposals can prevent entire features from being built on shaky foundations. Proactive problem detection. Identify fundamental flaws in logic, scalability, or security before significant development time is invested. Gather diverse perspectives. Solicit feedback from various stakeholders. Other developers, architects, product managers, operations teams. Focus on clarity, completeness, and justification. Is the problem clearly defined? Are the proposed solutions comprehensive, addressing all requirements, functional and non-functional? Are the trade-offs clearly articulated and justified? Are diagrams and flowcharts easy to understand? What-if scenarios. Perform mental walkthroughs of critical scenarios, including failure modes. What happens if the database is down? What if third-party API returns an unexpected error? Formal design reviews. For major projects, schedule dedicated meetings where the author presents their design and others provide structured feedback. This is a higher-level code review before the code exists. Summary. The art of code review deepens as you encounter more complex and specialized technical domains. Whether it's dissecting code for subtle security flaws, refining algorithms for peak performance, navigating the treacherous waters of legacy systems, or ensuring compliance with paradigm-specific best practices, the core principles remain: a critical eye, clear communication, and a collaborative spirit. Extending these principles to early-stage design documents can save immense time and effort down the line. In the next chapter, we'll shift our focus from the mechanics of review to how to measure its impact and ensure it continuously improves. Chapter 10. Measuring Success. How to know you're improving. You've invested time and effort in crafting a robust code review process. Your team is engaged, feedback is constructive, and tools are humming along. But how do you know if it's actually working? How do you assess the ROI, return on investment, of this vital practice? Measuring the success of your code review process isn't about shaming or micromanaging. It's about providing data-driven insights to affirm what's working well, identify areas for improvement, and demonstrate the tangible value of review to stakeholders. This chapter explores both qualitative and quantitative metrics, emphasizing a thoughtful approach to data to ensure it genuinely helps your team. Qualitative metrics. Team feedback, surveys, retrospectives. While numbers can tell part of the story, the human experience of code review is equally, if not more, important. Qualitative feedback provides depth, context, and helps uncover the why behind any quantitative trends. Team retrospectives. Purpose. Dedicated sessions where the team reflects on recent work, identifying what went well, what could be improved, and what puzzles them. Application to review. Regularly dedicate a portion of your team retrospectives to discuss the code review process itself. What's working well with our reviews? What's hindering our reviews? Are reviews being completed on time? Do we feel comfortable receiving feedback? Are we seeing an improvement in code quality? Anecdote. A team noticed a recurring theme in their retros: too many comments about formatting. This led them to implement an automated formatter and integrate it into their pre-commit hook, solving the problem and freeing up reviewers to focus on logic. Surveys and feedback forms. Purpose. Gather anonymous or attributed if psychological safety is high feedback from team members about their experience. Application to review. Create short, focused surveys. Examples of questions. On a scale of 1 to 5, how timely are reviews typically completed? Do you feel the feedback you receive is constructive and actionable? Do you feel empowered to give honest feedback without fear of reprisal? What aspect of our code review process could be improved most? Do you feel code reviews help you learn and grow as a developer? Benefit. Surveys can capture perspectives from quieter team members who might not speak up in a group setting. They are excellent for identifying trends over time. One-on-one discussions. Purpose. Gain deep, personalized insights. Application to review. As a team lead or manager, periodically ask individuals about their experience with code review during one-on-ones. How are you finding the review process lately? Are you getting stuck waiting on reviews? Do you have any ideas that could make our reviews more efficient or effective? Benefit. Allows for nuanced conversations and direct coaching around review practices. Qualitative feedback helps you understand whether the process is fostering collaboration, learning, and psychological safety, the true indicators of a healthy code review culture. Quantitative metrics. Carefully applying data with caveats. Quantitative metrics can provide hard data points, but they must be interpreted with caution. Misapplied or overemphasized metrics can lead to unintended negative consequences, e.g., gaming the system. The goal is to inform, not to judge or punish. Review turnaround time, RTT, /time to first comment /time to merge. What it measures: the elapsed time from when a PR is open to when it receives its first comment, its first approval, or when it is eventually merged. Why it's important. Shorter RTT means faster feedback loops, faster integration of changes, and less context switching for the author. Long RTT indicates a bottleneck in the review process. Goal. Aim for a low RTT, typically measured in hours. Ideally, a PR should receive its first review, even if preliminary, within a business day. Caveat. Don't sacrifice quality for speed. A rushed LGTM is worse than a slightly delayed, thorough review. Defect escape rate, what it measures. The number or percentage of bugs found in later stages, QA, staging, production, that should have been caught during code review. Why it's important. This is arguably the ultimate measure of the review effectiveness in catching bugs. If many bugs are escaping, it suggests the review process is not thorough enough or the focus is misplaced. How to track. Requires clear logging of where defects are discovered. Goal, reduce this number over time. Caveat, this metric can be influenced by many factors, quality of tests, complexity of code, etc., so isolate the impact of review as much as possible. Pull request size, lines of code changed LOC. What it measures. The number of lines added, deleted, or modified in a PR. Why it's important. As discussed in Chapter 4, smaller PRs are easier to review, have lower defect rates, and merge faster. Monitoring this helps encourage developers to break down large tasks. Goal, maintain a low average PR size, often 10 to 200 LOC, depending on context. Caveat, don't force developers to meet an arbitrary LOC limit if it sacrifices logical cohesion. The purpose is conceptual simplicity, not just line count. Reviewer engagement/review count, what it measures. The number of reviews performed per person over a period, or the average number of comments per review. Why it's important. Indicates active participation and shared responsibility across the team. Prevents review burden from falling disproportionately on a few individuals. Goal, promote shared review responsibility. Caveat, a high comment count isn't necessarily a good thing. It could indicate unclear code or excessive nitpicking. Focus on quality over quantity of comments. Code coverage of tests, what it measures, the percentage of your code base covered by automated tests. Why it's important. While not directly a review metric, it's a proxy for review quality. Higher test coverage means less human effort needed to verify basic functionality, allowing reviewers to focus on architecture and design. Goal. Strive for healthy test coverage, often integrated into CI requirements for merging PRs. Avoiding misleading metrics. Focus on value, not volume. The danger with metrics is optimizing for the wrong thing. Don't optimize for metrics that can be gamed. If you reward number of comments, you'll get more comments, but not necessarily better ones. If you only reward fastest review time, you'll get surface-level reviews. Metrics are a starting point for conversation. A declining RTT doesn't automatically mean your reviews are great. It means something is happening. Use the metric to open a discussion. Our average RTT is down, that's great. What do you think contributed to that? Are we perhaps rushing through reviews? Balance qualitative and quantitative. Don't just look at the numbers. Always cross-reference with team sentiment and actual impact on software quality. Continuous improvement loops, adapting your process. Measurement is not a one-time event. It's part of a continuous cycle of improvement. Inspect and adapt. Regularly, e.g., quarterly, or via dedicated review retrospectives, evaluate your code review process. Experiment, based on your findings, propose small, actionable changes to your process. For the next sprint, let's try enforcing a maximum PR size of 200 lines and see how it impacts RTT. Review the experiment. At the next retrospective, discuss the results of your experiment. Did it work? Did it have unintended consequences? Should we keep it, tweak it, or discard it? Document learnings. Update your team's code, review guidelines with successful changes. This agile approach to process improvement ensures your code review practices evolve with your team's needs, technology, and challenges. It stops the process from becoming stagnant or irrelevant. Practical tip. Encourage your team to spend 15 minutes in a weekly stand-up or end-of-week sync to explicitly review the review process. What's one thing we can do better next week? The link between code review and software reliability. Ultimately, the most important measure of your code review process is its tangible impact on the product. Fewer production incidents. Are you experiencing fewer critical bugs or outages that are traceable back to code quality issues that should have been caught in review? Happier users. Does improved software quality lead to fewer customer complaints, better user experience, and higher user satisfaction. Faster feature delivery. By catching errors earlier and reducing rework, are you able to deliver new features and improvements to market faster and with more confidence? When done well, code review directly contributes to all these positive outcomes, making your software more reliable, your users more satisfied, and your development cycle more efficient. Summary: measuring code review success requires a balanced approach. Utilize qualitative feedback to understand the human experience and cultural impact, and quantitative metrics to highlight trends and bottlenecks. Always interpret data with caution, avoiding the trap of false metrics. Most importantly, embrace a continuous improvement mindset, regularly inspecting and adapting your process based on insights. By doing so, you ensure your code review practices remain a powerful, dynamic force for quality and collaboration, demonstrating their immense value to every stakeholder. In our next chapter, we'll delve deeper into cultivating this culture of quality. Chapter 11, Building a Culture of Quality Through Review. Throughout this book, we've emphasized that code review is not merely a technical process, but a deeply human one, an intersection where code, communication, and collaboration converge. The cumulative effect of consistently practicing effective code review is nothing less than the cultivation of a robust culture of quality. This culture is characterized by shared ownership, continuous learning, and a collective commitment to excellence, ultimately leading to superior software and a more engaged, high-performing team. This chapter explores how to intentionally nurture such a culture, transcending mere process adherence to embed quality into the very DNA of your development team. Leadership buy-in and championing code review. A culture of quality doesn't spontaneously emerge. It is intentionally fostered, often through visible leadership. Managers and technical leads play a pivotal role in championing code review and setting the tone. Model desired behavior. Leaders must lead by example. This means actively participating in reviews, giving thoughtful, constructive feedback, and graciously receiving it. If management prioritizes speed over quality and bypasses reviews, the team will quickly follow suit. Allocate dedicated time. Reviewing code takes time, often significant time. Leaders must acknowledge this and factor it into project planning and individual work schedules. Expecting developers to review on top of their full development workload without accounting for it is a recipe for review fatigue and superficial feedback. Quality is not free, it requires investment. Recognize and reward good reviewing, value the act of reviewing. Too often, writing new code is rewarded, but the quiet, painstaking work of improving others' code goes unappreciated. Recognize individuals who consistently provide excellent reviews, mentor others, and contribute significantly to code quality through their review efforts. This sends a clear message that reviewing is a valued contribution. Elevate the importance of quality. Regularly articulate why quality matters to the team, the business, and the users. Connect effective code review directly to reduced bugs, increased user satisfaction, and faster feature delivery. Make quality a core team value, not just a technical requirement. When leadership actively champions code review, it signals to every team member that this process is integral to success, not just a bureaucratic hoop to jump through. Making code review a positive and rewarding experience. If code review is perceived as a critical, negative, or simply boring task, it will never be embraced. For it to become a cultural cornerstone, it needs to be seen as a positive and rewarding experience. Celebrate good reviews. Publicly praise thoughtful reviews. Great job, Alex, on that review of Sarah's PR. Your suggestion to use the caching layer significantly improved performance. Acknowledge authors who handle feedback well. Props to Ben for taking on that complex refactor suggested in review and implementing it so cleanly. Consider a Reviewer of the Month or a similar informal recognition. Keep it light but meaningful. Focus on the shared goal. Remind everyone that code review is about building great software together. It's a collaborative process where collective intelligence improves individual contributions. Frame mistakes as learning opportunities. In a healthy culture, mistakes are not hidden or punished. They are openly discussed as avenues for learning and improvement for the entire team. This fosters a growth mindset. Create a learning environment. Encourage the use of reviews as a space for teaching and asking, why? If a reviewer simply states, change X, encourage them to explain the reasoning, which benefits the author and reinforces the reviewer's own understanding. By actively cultivating a positive atmosphere around code review, you move it from a compliance gate to a genuine driver of morale and excellence. Training and education for effective reviewers and authors. While some skills are learned through experience, formalized training can significantly accelerate the adoption of effective review practices and ensure consistency across the team. Workshops on giving constructive feedback. Teach developers how to phrase comments, use I statements, explain the why, and focus on objective facts rather than personal opinions. Role-playing scenarios can be particularly effective. Workshops on receiving feedback gracefully. Help authors develop strategies to detach ego from code, ask clarifying questions, and engage constructively with critical feedback. Pairing on reviews. Encourage senior developers to pair review with junior team members, walking them through the process, articulating their thought process, and demonstrating how to provide valuable feedback. This mentorship is invaluable for skill transfer. Establish internal guidelines and best practices documentation. Make your team's specific expectations for PR descriptions, review etiquette, and coding standards easily accessible and regularly updated. This serves as a continuous learning resource. New hire training. Integrate code review best practices into your onboarding program. Explicitly teach new hires how your team approaches reviews, what tools are used, and the cultural norms around feedback. Investing in consistent training ensures that everyone on the team is equipped with the skills and understanding necessary to participate effectively in the code review process. The role of peer recognition in driving adoption. Humans are social creatures, and peer recognition can be a powerful motivator. When colleagues acknowledge and appreciate each other's contributions to reviews, it creates a positive feedback loop. Informal shoutouts, a simple thanks for the thorough review name, in a team chat or a specific mention in a stand-up can motivate. Internal communication channels. Create a channel, e.g., in Slack or Teams, dedicated to wins or shoutouts, where team members can publicly acknowledge great contributions, including insightful reviews or gracefully handled feedback. Highlighting valuable review comments. If a reviewer provides an exceptionally insightful comment or asks a particularly thoughtful question, highlight it within the team as an example of excellence. This informal, ongoing recognition reinforces the value proposition of code review amongst the peer group, making it an organic part of the team's identity. Beyond code. Applying review principles to other areas. The review mindset. The application of critical thinking, constructive feedback, and collaborative improvement is a portable skill. Encouraging its application beyond source code reinforces its value and strengthens overall team processes. Design document reviews. Before writing a single line of code, review architectural proposals, system designs, and technical specifications. This catches issues at the highest, most influential level. Peer reviews for technical specifications. Review everything from user stories and acceptance criteria to database schemas and API definitions. Retrospective/postmortem reviews. Apply a critical, no-blame review mindset to past processes or incidents. What went wrong? Why? What can we learn? How can we improve? Project plan reviews. Have team members, beyond just project managers, review project plans for feasibility, risks, and clarity. By applying review principles broadly, you cultivate a continuous improvement culture where critical self-reflection and collaborative refinement are the norm for all aspects of work. Summary: building a culture of quality through code review isn't an overnight endeavor. It's a continuous journey that requires commitment from everyone, especially leadership. By actively championing the process, fostering a positive environment, investing in training, and celebrating contributions, teams can transform code review from a mere process into a fundamental pillar of their engineering culture. This culture empowers developers, elevates software quality, and ultimately drives greater business success. In our final chapter, we'll look ahead to the future of code review and its ongoing evolution. Chapter 12. The future of code review, continuous learning and evolution. We've journeyed through the intricate landscape of code review, exploring its myriad benefits, grappling with its human complexities, harnessing its technological muscle, and understanding its role in shaping a culture of quality. From its early origins in formal inspections to its modern manifestation as the ubiquitous pull request, code review has demonstrably evolved, becoming an indispensable practice in software development. But the story doesn't end here. The tech world is dynamic, constantly producing new paradigms, tools, and challenges. Code review, too, will continue to evolve. This final chapter looks ahead, considering emerging trends, the growing synergy between human and artificial intelligence, and the enduring principles that will define the future of this essential art form. Emerging trends in code review technology. The technological advancements shaping our world are inevitably spilling over into how we review code. More sophisticated AI assistants. Beyond today's static linters and basic suggestions, expect AI to offer deeper contextual understanding. This could include identifying potential performance bottlenecks based on usage patterns, suggesting alternative patterns learned from vast code repositories, or even generating comprehensive summaries of complex pull requests to aid human reviewers. Improved integration with IDEs and other tools. The review experience will become even more seamless. Imagine real-time collaborative editing with integrated code suggestions from an AI, or review comments that directly interact with your integrated development environment, IDE, allowing you to apply fixes or generate tests with minimal friction. Real-time collaborative review environments. While asynchronous reviews offer flexibility, there's a growing interest in tools that facilitate more real-time, synchronous collaboration for specific scenarios. Think of a shared code editor where reviewers and authors can discuss code, highlight sections, and even refactor together instantly. Context-aware analysis. Tools will move beyond simple rule-based analysis to understand the code's purpose within the broader system. An AI might suggest, this new feature introduces a potential race condition given its interaction with the order processing service across different microservices, a level of insight traditional static analysis struggles with. Blockchain for auditability. While speculative, blockchain technology could potentially offer immutable and transparent records of code change and review history, particularly appealing for highly regulated industries requiring stringent audit trails. The human-AI collaboration in software development. The most significant trend shaping code review is the evolving relationship between human reviewers and artificial intelligence. This isn't a zero-sum game where one replaces the other. It's a powerful synergy. AI taking on the tedious, repetitive checks. AI and automation will increasingly handle the mundane, repetitive, and rule-based aspects of code review. Syntactic correctness and style adherence. Basic security vulnerabilities. Simple logical errors. Performance anti-patterns. Ensuring test coverage. This frees up human reviewers from nitpicking and allows them to focus on what only humans can do. Humans focusing on complex logic, architectural soundness, and nuance. The human reviewer's role will shift to higher-order cognitive tasks, architectural vision. Does this change align with the long-term architectural goals? Business logic and user experience. Does the code truly solve the business problem and delight the user? Strategic trade-offs. Evaluating the subtle compromises between performance, maintainability, scalability, and delivery speed. Ethical implications. Considering the societal impact and ethical considerations of the software being built. Mentorship and knowledge sharing. The invaluable human interaction, teaching, and learning that builds strong teams. The future reviewer. More of a coach and mentor. In an AI-augmented future, the human reviewer will spend less time finding obvious errors and more time guiding, questioning, and nurturing the growth of their teammates. They will become curators of best practices and stewards of architectural integrity. This human-AI partnership promises a future where software is developed faster, with higher quality, and where developers are empowered to focus on the most creative and challenging aspects of their craft. Code review as a cornerstone of DevOps and continuous delivery. The principles of fast feedback loops, automation, and continuous improvement central to DevOps and continuous delivery, CD, are precisely what effective code review enables. Faster integration. Automated reviews allow developers to merge code to the main branch more frequently, reducing integration hell and enabling truly continuous integration. Maintaining quality at speed. In a world demanding ever faster release cycles, manual gatekeeping becomes a bottleneck. Automated and streamlined code review processes ensure that speed doesn't come at the cost of quality. Shift left, security and quality. By integrating automated security scans, quality checks, and thoughtful human reviews early in the development lifecycle, i.e., shifting them left, problems are caught and fixed at their least expensive point. Code review is, and will remain, an indispensable strategy for delivering reliable software at the speed required by modern markets. The ever-evolving art of building great software together. Despite all the technological advancements, the fundamental art of code review will endure. It is rooted in human skills that transcend any specific tool or programming language. Communication, the ability to articulate complex ideas clearly, concisely, and empathetically. Empathy, understanding the author's context and intentions and choosing words that foster trust rather than defensiveness. Critical thinking, the capacity to analyze, question, and improve, not just validate. Collaboration, working effectively with others towards a shared goal, recognizing that the team's output is greater than the sum of its individual parts. Continuous learning, a willingness to admit what you don't know, embrace new ideas, and constantly seek to improve your craft and your process. Software development has always been, and will likely remain, a deeply human endeavor. It's about people solving problems for other people. And in this intricate dance, code review serves as a vital ritual, a continuous conversation that brings out the best in both the code and the people who create it. Final thoughts and call to action. You now possess a comprehensive understanding of the art of code review. You've learned its profound benefits, its psychological nuances, the tools that empower it, and the culture it cultivates. Don't let this knowledge remain solely theoretical. Pick one thing, choose one new best practice from this book, whether it's meticulous PR descriptions, a commitment to smaller PRs, focusing on the why in your comments, or actively seeking feedback, and commit to implementing it in your daily work. Start a conversation, share these ideas with your team. Propose a short discussion in your next retrospective about how you might improve your current review process. Be a champion of quality. Whether you are an individual contributor, a tech lead, or a manager, advocate for effective code review. Lead by example and help others see its transformative power. Code review is not a destination. It's a continuous journey of improvement. It requires practice, patience, and persistence. But the rewards, higher quality software, faster delivery, reduced technical debt, and a more knowledgeable, collaborative, and engaged team are immeasurable. Thank you for embarking on this journey. Now, go forth and master the art of code review, transforming your code and your team, one thoughtful review at a time.